Hello and welcome to 3.4 day 2. We're going to finish up the constructions from 3.4, and those constructions include an angle bisector, equilateral triangle, and parallel lines. So we're going to start off with the angle bisector. And remember from yesterday we did a perpendicular bisector. It's going to be somewhat similar to that, except now we're bisecting an angle. So remember, a bisector means to divide into two parts. So when we are looking at this angle, we want to find that segment that cuts the angle into two equal angles. So what you're going to do first is take your protractor, and just like we did when we duplicated an angle, we're going to make any arc on there. Now, usually you don't ever change, once you make the arc, you don't change the width of the protractor, and that's going to be the same here. We don't want to change that width, and now as usual, we're going to the intersection, and we're going to make an arc, and we go to the other intersection, and we make another arc. And notice we get two intersecting lines. So what this did is it's saying, we made this arc with the same distance, so from here to here is the same distance to B. And then from the intersection to this arc is the same distance as the intersection to here. So that must divide this into two equal parts. So take your straight edge, and you're going to draw your line from the vertex of the angle through there, and that is our angle bisector. And we're going to draw a little arrow on the end because it's a ray, can continue on forever. So our angle bisector for angle ABC is drawn there. My line does not go exactly through my vertex, but so if you look, this angle is congruent to this angle, so remember we need to mark that. So that's congruent to this. So next, let's keep it simple with our steps. First, made an arc on the angle. Second, went to the intersections. Excuse me. Ooh. Sorry about that. Hope that wasn't too loud. Went to the intersections and made two more arcs. And lastly, from the vertex, drew a ray through the intersecting arcs. Sorry, I'm a slow writer. So let's reiterate that. Made an arc on the angle. Went to the intersections, which when I say intersection, I mean where the arc intersects the angle. And we made another set of arcs right here. And then we drew a ray from our vertex through our angle and marked that the two angles were now congruent because we bisected them. All right? So if you need to redo that, go ahead and rewind it. Otherwise, we're going to move on to constructing an equilateral triangle. Okay, what I want you to notice is in an equilateral triangle, if I were just going to do a rough sketch over here, an equilateral triangle means all sides are equal, and also that means all the angles are equal to 60 degrees. So when it says construct an equilateral triangle, that's really the same thing as constructing a 60-degree angle. So if I ask you to construct an equilateral triangle, or I ask you to construct a 60-degree angle, you're going to follow the same steps we do after this. So what I want you to do is to duplicate segment AB. So this goes back to 3.3. We learned how to duplicate or copy a segment. So I'm going to pick to start my point down here. And I want you to duplicate the segment. Move this down so I can see my... So I can see the top of my compass. So take your compass and measure the length of AB. And go down to your origin new point and make an arc. And for this first one, we can pick any point on that arc to be our B. So I'm going to pick that point. So this is our A, here's our B. Use your straight edge and connect the dots. All right, so we have the start to our triangle here. Now, do you agree that an equilateral triangle, you need to have all the sides be equal? So my compass here is already the length of AB. I've already measured it. So from point A, C is going to be somewhere up here. I know that it has to be the same distance away from A as it is from B. So this distance here has to be the same as this segment AB. And I also know that the third side also has to be equal because it's an equilateral triangle. So I also have to do the same thing from point B. To get to point C, it has to be the same distance from B. So I make a third arc. And I found my intersection. That is my third point on the triangle. I'm going to call that C. So what I'm saying is from A to B is the same distance from B to C as it is from A to C. So all three of those distances are the same. That means I've constructed an equilateral triangle. So I'm going to take my straight edge and I'm going to draw in the segments. If I can get it to work. Right, good enough. There's one. And here's the last one finally. Gee, come on. All right, and there's my last one. Now it's not quite perfect because my tools are a little bit more difficult to use than paper pencil. But what I need to draw on this is this segment is congruent to this segment as it is to AB. So all three sides are equal, and notice that all of these angles are also going to be 60. So if I asked you to construct a 60-degree angle, all you'd have to do is construct AC and AB, and that would be a 60-degree angle. So let's keep our steps short and sweet. Write in red, switch it up. Okay, first we duplicated AB. Whoops, what'd I do? How'd that happen? Oh well. Second, from both endpoints. Whoops, I forgot my S. Whoops. From both endpoints, we made an arc. And remember that arc had to be the same distance as segment AB, so we got all three sides equal. And lastly, once we got the intersection, we connected all our points together. You know, those directions are pretty vague. I know I wrote more detailed ones in class. What will benefit you most is just going back and watching the construction. Okay, or maybe even writing it down in your own words. So next we're going to look at number 6 and 7. Now they're going to be very simple, and the thing about these constructions is yours may not look the same as mine. It is still an accurate construction, whereas everything else should look the exact same when you construct it. This might be a little bit different. So first we need to learn a little bit of terminology. They're asking us to construct a triangle inscribed inside of a circle. So inscribed is the key word here. I'm going to underline inscribed. That's the key word. Okay? And it's inscribed inside of circle. So what that means is visually we're going to have a circle with a triangle. Oops, that was not a good picture. Ooh, that's terrible. All right. Inside we're going to have a triangle. That's still terrible. Get the idea, I hope. Inside we're going to have a triangle inside of our circle. So what I want you to do, oh, that was awful. Bear with me. Okay, so we're going to construct a circle. Any circle you so choose. There's my circle. Right. And since they didn't give me a specific triangle, I can pick the triangle I want to draw in here. So if it's inscribed, that means the vertices of the triangle need to be on the edge of the circle. So all I do is pick 3 points. That's going to create a triangle. I'm going to take my straight edge. Since they're asking me to construct, my lines need to be perfect. I'm not sketching here. All right, so if I can get this to cooperate with me a little more. Right, so I'm going to construct my first segment right there. Go to construct my other one. And then my last one. Stand the ruler. Okay, and I'm finally going to get my last one. I hope you could do this a lot quicker on paper. So there's my triangle inscribed in a circle. You notice the next one, they just changed the terminology on you. The key word here is they want you to construct a triangle circumscribed around a circle. So you can think before we had a circle with a triangle on the inside, now we're going to have a circle on the inside of our triangle. So you're going to start by constructing any circle you choose. Don't make it too large though, because remember the circle is going on the inside of a triangle now. And what we're going to do now is, it didn't tell us what triangle we needed. We're going to learn how to do that later. Right now we're only starting from a circle. We can draw any 3 lines on the outside. And a tangent line is what we're actually going to draw. And a tangent line means it only hits your circle once on the outside. So it hits it at one point. So I'm going to draw a line going that way. And just make it extra long in case so you can see they connect. I'm going to draw another one over here. And my third one can go somewhere over here. Now I have that circle that's on the inside of my triangle, so the endpoints of my triangle are the vertices right there. So I have a triangle with a circle now on the inside. Circumscribe means that the triangle is around the circle. All right, and the last construction we need to do, not that one, that was your homework yesterday, is parallel lines. And this one's not in your packet, so I'm just going to use example 14. In class, we did a separate example, but I'm just going to go through number 14, the steps that I would take to construct this. So remember when we drew, oops, that's not what I wanted. Remember we drew perpendicular lines with our protractor? We started with a line and then we drew a perpendicular and then we drew another perpendicular. We're going to sort of do the same thing, but now we need to construct. So we can no longer use the protractor. We can only use our compass and our straight edge. So what I want you to do first is to construct a perpendicular line from point A to the line. Now we did this construction yesterday. We start with an arc. We go to the intersection. We make an arc below. And we make an arc from the other intersection. Oh, I made the... All right, so I've just constructed a perpendicular. Take your straight edge and draw a line from the point through the intersecting lines. I'm just terrible with this ruler. Oh, I hope you're better with your ruler. All right, so I'm going to draw a line now. There's my first perpendicular. Okay, but I don't have any other point of reference that I can use to draw my line, because to create a line I need 2 points and I only have point A. So what I'm going to do is I'm going to pick another point over here. I can put it anywhere. I'm just going to pick it there. And I'll move it a little closer. And I'm going to repeat the same process I just did. I'm going to construct a perpendicular from that point now. So do your arc, intersection, another arc. The other intersection, you're going to do your third arc. Oops, hit undo, undo. All right, there it is. There's my second perpendicular line now. I'm going to draw a line there now. So there's my second perpendicular line. And lastly, I need to measure the distance between my line and point A, because parallel lines are always going to be the same distance apart. So these parallel lines need to be the distance from the line to point A. I measure my distance, go here. I'm going to make an arc over here at the distance I need to draw my second point. And I've now found a second point to draw my line. Plot that, take your straight edge. Whoa. And connect those two. Right. So I've just constructed a parallel line through point A. Now, there's not a place to write our steps, so I'm going to jot them over here. So I'm going to keep it simple. We constructed perpendicular line from A. Then we created a new point. And constructed a second perpendicular line. And lastly, the key thing is we can't just draw it through that point we picked because we don't know that it's the same distance as from our line to point A. So we have to measure the distance. From the original line to point A. And do the same thing on our second perpendicular line. Which is where we made that arc. And lastly, draw a line through those 2 points. And it is now parallel. All right, so this is probably one of the most difficult ones we've done today, but notice that we haven't added really any new construction. We just constructed 2 perpendicular lines, and then make sure you remember to measure the distance from our line to point A on this line, okay? So your homework for today then is going to be the rest of section 3-4, which is now page 53 through 54, and it's going to be numbers 14 through 18. At some point, I may make a video going through some of those problems, but my video is getting long because I'm really terrible at using the ruler. So I hope this helps you guys with the 5 new constructions we've added. Have a good day.